Yeah, I think I'm back online now. Seriously? Why did it go offline? Okay, well now the YouTube stream is ended. This sucks. I mean, it would be really hard to like build a product like this, honestly. Like restream or whatever. It's not easy. It's not easy because there's like a fairly wide ecosystem of like products, like, and you have to like write a bunch of code that's specific to each API, and then deal with like minor issues between each API. But the point is, so I was talking about systems and the distinction between open systems and closed systems, and using like a well-known anecdote from Warren Buffett's like early investment days to illustrate the ideas behind. Oh, I really did that, huh? Who said that you get in my stream? And using the ideas from Warren Buffett's early investment days to illustrate the difference between closed systems and open systems, and how that makes it more efficient to reason about like systems in general. And so there's two different approaches. One is to like work within open systems and to maybe like learn about new stocks that you're going to trade, and you're thinking about like, oh, like, do I want to trade in Apple stock? Do I want to trade in like, NASCAR stock? Do I want to trade in like I don't know if NASCAR has a stock. I guess you could trade ESPN or something, or Disney or whatever. Um, anyway, so like, and you learn about new products and new companies that you can invest in, and you learn about like the dynamics that are specific to those stocks. So you have to learn like what the market capitalization is, like whether it's a volatile stock or like is it in a volatile industry. What stocks and what industries is it correlated to? Like what news sources can you identify that would tell you what is a good inference to make for investment decisions? Like what's an accurate inference? Um, huh, I really can't believe it. It must be streaming to another video. Anyway, so you're learning about new things one at a time. There's this system, and to you it appears infinite, and you can't see the end of it. Maybe you see the end of it, you see the outlines, but you don't think of it in terms of a closed systems approach. Warren Buffett got the Moody's index. I don't know what it is specifically, but it's something called Moody's, and it's like a set of volumes. It's almost like a set of encyclopedias for the stock market that like stock investors used to use. And it covers all of the information about stocks that are available to trade on Wall Street. And so Warren Buffett approached stock trading from a closed systems perspective. He memorized so much information from Moody's, which was like a complete encyclopedia of like companies you could invest in, and picked out like penny stocks. But he was like very moral, or he had a value centered approach to penny stocks. So it's not Wolf on Wall Street. Let's find the penny stocks, exploit it, like create a false like dynamic, blah blah blah, that allows people to think that if they put all their money in the penny stock, they're getting like the value's going to inflate, and then we pull out early, make a lot of money. It's not like that's one way that you can exploit penny stocks in new companies, but like you're going to find that if you're moral with like how you manage your money, like if you have strong values and you make values oriented investment decisions, you're going to find that like you're rewarded. You're going to find basically that karma is real. Like you're like, because like for Warren Buffett, he wanted to find companies that he believed could be turned around, that were run by good people, that could be turned around. or that were run by people and would be profitable if he turned them around. So he he memorized like all this data from Moody's and the Encyclopedia for Wall Street in like I guess the 60s, 70s, before the internet, basically, and and then approached investment in terms of like looking at all these numbers and all this data before that was like easy to do, and he approached the system like from a closed perspective, like give me all the data. I want to see all the data. I want to find. I have like a pattern in my head of companies that I want to like pursue for like possible investment because I know I can make money like on enough of these, and if I find the right ones, I can turn these people's lives, these businesses around, and do it in a way that like returns me value, but also allows me to help good people that deserve another another chance or deserve their company to be looked at in a way that like can result in it turning around. Anyway, it's just like it's interesting to think about like how he pursued that, how and why he picked the closed systems approach because it's a lot of work at first. You have to learn you have to learn how to even measure the limits of the entire system, and then you have to find the boundaries, and you have to consume like the surface of like all the data that that informs you as to how to invest your effort and your time to find the more valuable pieces of information. But instead of like the open system approach where you're like gradually accumulating your knowledge base, you start with the closed system, the whole thing, which takes a lot more work, and then like identify the opportunities or the piece of information that you need to like prioritize your effort or you prioritize your time to orient towards. So, but how did I get into that? I have no idea. Oh, great. The live stream cut out again. Oh, well. One of these deserves to be out. I'm going to have to go back and check the stream. There's a 4-4. I think it was 9-4-4. I'm going to have to check and make sure later. 9-4-4, that would be a 7. 8. 8. Oh, damn it. This is why I don't want to talk and stream and try to do I Ching readings at the same time. I'm likely to do something stupid like that. I'm like almost certain it was a 9-4-4. But I'm going to go back and check that. Don't you hate that? You get to like the 5th one. And so this is so far like so there's two hexagrams that this could be at this point. If this is indeed a 9-4-4, we'll find out. I will anyways. So there's 2 hexagrams it could be. It could either be holding together or it could be contemplation. Changing into something else. Changing into the other one actually. Changing into, well, I'm not going to worry about that. I'm going to hurry up and sample the rest of this and finish this. Alright, that idiot. The fucking, like, feed distracted me. Like talking about all this highbrow like Warren Buffett, closed systems, open systems. But really, like, how do you think? Like, it's what's like. It's very powerful to learn how to think. Like, what's the best way to think? Like, how do you like learn to analyze something very quickly and like navigate like a new system of knowledge or information very quickly, and then like how do you discover like when you need to reorient yourself? I'm pissed about that because I don't think I can like. Probably gonna have to cut the feed and then maybe make a post about like what it actually means for explaining a special theory of information to a 5-year-old. I would like to know that because like if you can explain something to a 5-year-old, like in terms of age, that means any person like 5 years or older could conceivably understand what it is you're talking about. 5. Damn, these things were expensive. These like sticks were like $20. They're like $25. They came from China. They smelled funny when I opened the package. I don't know what they smell like now, but I think they've been blessed. You can't just like go outside and get new sticks. That's the one. That's not allowed. Because they seem to work pretty good. I don't know if any old like set of sticks. Like I would rather have the yarrow stalks than like to have the nice like neat like leaching stalks. Because I feel like there might be something magical about this plant. But maybe not. I don't know. If woo-woo physics, if quantum woo is real, then there really could be something about the yarrow stalks. It really depends on whether quantum woo is a real thing. I would prefer to not believe in quantum woo because I understand like how easy it is for like entanglement and other phenomena to break down in terms of like because of thermodynamic like noise and stuff. Like so essentially like quantum mechanical like things like entanglement like only really show up at you can only really study them in like extremely cold temperatures because otherwise they disappear. And there are some exceptions to that, depending on what you're studying. But you know what is still maybe like woo physics for real is quantum information theory. So quantum information theory, like woo physics might imply, like so if you can have entangled information, then you can. That's what I'm sort of writing about. Then you can apply like some insights from woo physics, quantum woo, like to information theory. But you have to realize like the quantum mechanical things don't really necessarily apply, or they break down quickly. Oh, I've got these fascinating ideas on disnormalization. That's actually some like there's some pretty important ideas in there. So like how do you like intentionally break down ideas and norms, ideas about norms? That's a 4. And what happens when like society is so postmodern that there are no norms? It becomes like, or the norms are so myriad that like you can't make very good assumptions about the norms, about what norms are or how they're going to come together when they start to form, or the influence that norms and beliefs about norms have on society, like because it used to be that like norms would form very slowly and they would be regionally bound. And then now we have the internet and social media, and norms spread very quickly. Beliefs about norms spread very quickly because we have to form new beliefs. We have to make normative beliefs and normative assessments. Um, we have to make assessments about norms and make inferences about norms in a very quick and nimble way in the 21st century because like life is changing so quickly via technology and like an example of this is in like user interface design and user experience design. Like, so if you're like at Netflix, like making decisions about how to arrange elements in your user interface, or especially Facebook. Facebook's a really good example because if you're going to make a change in the user interface design, or a change in how the algorithm works, the newsfeed algorithm works for like Facebook groups or whatever, like people are going to react to that, but their reaction is going to lag. So you make the change, people decide they hate it or they love it. Like remember when everybody hated the new Facebook? Oh no, Facebook changed. Oh my god, it's so horrible. Blah blah blah. Like now, Facebook changes all the time and nobody cares, or it changes in ways that people can't see it. But the point is, like, norms about technology take time to form, but when technology like is changing and like the user interface and user experience side of technology changes faster than norms can be formed, then people can't make like they can't make normative statements about how to use technology or what the most effective way to use technology is or how does somebody use Facebook wrong, like what's the wrong way to use Facebook, because like you can't make the because the technology changes so fast that any like assessment, like you can't measure the norm as just a user. Like you can't really form an intuition for what the norm is as a user because by the time you've formed that intuition of what that is, or by the time you've talked to your friends to understand how they use technology, the technology has changed and any normative like beliefs that you formed are no longer valid. And so like and there's some like very interesting um there's some very interesting extrapolations to that because there's a point at which it's like sort of like butting up against like in terms of singularity it's sort of like butting up against like Mach 1 or Mach 2 or I guess Mach 1 and like getting up close to the speed of sound and then all of a sudden like this new dynamic appears and the new dynamic is like the consequences of a sonic boom because now you're moving and I'm not trying to like glorify the like technological progress in terms of like aerodynamics but you're approaching Mach 1 and certain dynamics form and then you actually break past the speed of sound and like you get this like vacuum like a small vacuum like and maybe a larger vacuum I don't really I didn't major in aerospace engineering of course but you get a vacuum that forms that results in a sonic boom. So the sonic boom is the completely novel like dynamic that emerges. So before you hit Mach 1, there is no sonic boom. Like that dynamic doesn't exist. You cross past Mach 1 and the sonic boom begins to emerge and begins to get much louder and the consequences like mechanically on the structure of the aircraft start to become relevant. But the point, like how that relates to normatization and the formation of norms as it results to as it relates to technology and evolution in technology, is so like you're getting like your technology is evolving faster and faster. The rate of evolution in technology is accelerating, and so we're not concerned with the velocity of progress in technology. We're concerned with the acceleration of progress in technology and the ability of people to form any normative beliefs, any beliefs relating to norms and like what the normative response should be if you want to influence how other people form beliefs about technology that may or may not be normative. Like their ability to do that in any capacity changes and breaks down. And so that's like hitting Mach 1. So all of a sudden you have dynamics that emerge because you no longer can, and it's not such a sudden transition as Mach 1, but it's like suddenly your like society's ability to make reasonable assumptions about technology and make assumptions about other people's like perceived norms as it relates to the experience of technology or the use of technology, like suddenly that ability breaks down and it no longer functions, and it's a consequence of the informational dynamics of the like the dynamics of information, because people can't adapt to the new like user interface changes, or businesses can't tailor their business models like fast enough to respond to changes in technology and disruptive markets and disruptive products. So I got a 5, 4, 8, and that's another 8, I think. Yeah. Okay, so this is what the hexagram looks like. Enthusiasm again. What? That's bullshit. I got this same hexagram, like a slightly different reading of it. I got enthusiasm unchanging. I gotta go back and check this 944 on the video and make sure that that's correct. It was enthusiasm changing into the receptive. So I think I'm done for now. I'm gonna just like analyze whatever this this hexagram means. I mean, let's see what line. Actually, I can do it right now. I'm fairly familiar with this one. I just got it. I basically asked the I Ching. I was like, I Ching, should I be an idiot on social media? And I Ching's like, be as loud as you want. And I was like, that's bullshit. And now I just got it again. Let's see how so there should be one line that I have to read. It's the 4th line. And so I gotta go check the video to make sure, I should be able to see what my reading was. To make sure. But, oh wow, this is nice. So I Ching, how do I explain spatial information theory to a 5-year-old? And I Ching's answer is, the source of enthusiasm. He achieves great things, doubt not. You gather your friends around you as a hair clasp gathers the air. And this is like a reference to the Laplacian, and it's very relevant to normatization and normification. Whoa. So that's like me illustrating the hair clasp. But basically, people form norms related to core beliefs about norms. And enthusiasm is the I Ching's analog for the socio-physical Laplacian. It's talking about how to influence other people's behavior and how to read people's behavior and statements as they relate to anticipation of dynamics and trends in society. So actually, this is very relevant to spectral information theory. Because it talks the image of enthusiasm is thunder comes resounding out of the earth, the image of enthusiasm. Thus the ancient kings made music in order to honor merit and offered it with splendor to the supreme deity, inviting their ancestors to be present. So it's talking about music, and it's talking about music that changes people's values. like changes people's values or their conception of morality. Um, and it's like music as I have notes here. Music as regulated channeling of enthusiastic energy, or and I also have another note in here: enthusiasm as signaled intent, or the intended direction of energy investment signaled. So it's like talking about like signaling your intent, and it's it's relevant to it's relevant to special information theory. But I mean that's how it always seems to work. Is that there's always some like if your question is good, there's always some like a lot of value in here. And I have to go out and read the other one. So it's enthusiasm changing into the receptive, which is basically like so it's basically like the source of enthusiasm. He achieves great things. Doubt not. You gather friends around you as a hair clasp gathers the air. That seems like the opposite of the truth, but we'll just humor the I Ching for a while. And then it tells me to read the receptive, and it says, when there is hoarfrost underfoot, solid ice is not far off. And there's another video where I talk about that line for like 45 minutes. Straight, square, great, without purpose, yet nothing remains furthered. Hidden lines. One is able to remain persevering. I might have gotten this one wrong. One is able to remain persevering. If by chance you are in service of a king, seek not works, but bring to completion. Dragons fight in the meadow. Their blood is black and yellow. Black and yellow, black and yellow. Lasting perseverance furthers. I don't get that one actually. Oh. 6 in the 5th place means a yellow lower garment brings supreme good for fortune. I need to change my underwear. Dragons fight in the meadow. Their blood is black and yellow. So, I'll have to analyze this. I don't understand what the receptive means, but I do understand sort of what the, because this is the line that was like, that, for me in enthusiasm, I was like, that's the socio-physical oppression. Because it's talking about like what people perceive the norm to be, or what people perceive like the direction of society to be, or the direction of like, I guess with as it relates to spectral information theory, like what this line is talking about is like the first statements that come out after an event happens. Like it could be a tragic event, or it could be like a really good event, but the importance of the news is like it's important to people. It could, and usually this happens when there's a tragedy, and people are like, "Oh my god!" and they rush to their phone and they pick it up and they're like, "Ah!" Or it could be like a really good thing, like Apple just crossed $1 trillion valuation. Like that's like whoa, like that's a positive thing. But everybody, like it makes people think, it makes people change their conception of like how society is progressing, because social dynamics, like because they're informational, are not nearly as like visual as physical dynamics. So like because the system is physical, I can tell that the water's moving around. I can make very very clear assumptions related to the Laplacian, kind of, about like whether or not I'm going to spill the water, or whether or not like, yeah, I can make like maybe a glass of water is not the best way to explain it, but the point is I can see like what's happening with social like dynamics. You can't necessarily see; it's non-visual. You can't necessarily see what's happening, but people still try to find out, and that's what the anticipation is about. So people move towards where there's enthusiasm, or like loud signal and high amplitude signal. So when something critical happens, people like look for like if something critical happens, news is released about some event, like people look for the high magnitude, like the loudest like news coming out about that event, and they form normative beliefs, and like you want to get them to form beliefs that are like um, amenable to your own cause or your own goals. Um, like you want the beliefs that are formed first, the beliefs about norms about the events also, like both. You want beliefs about the event and beliefs about norms about the beliefs about the event. You want those to be in your favor at first, because once those are set, they're difficult to change. And that's what this line is about. It's about like that's what this whole hexagram is about, but especially this line. It's about the Laplacian for socio-physical like things. So the Laplacian in physics is like it's like a vector calculus operator that tells you like what like it's either the gradient of the divergence or the divergence of the gradient. I think it's the divergence of the gradient. I'm gonna look it up real quick so I get it right. But basically, it's like the magnitude of change over some area. And it's like these pictures suck. So you want to be able to set like for a vector field heat map. So I'm going to explain it in these terms. So here's a soccer field. And so if you're like, what is the Laplacian of the soccer field? So if you imagine that this is a heat map that's an aggregate of, I guess, like the players' positions on the field. And so you can see like where people spent the most time on the field. But if you took, like, if this was instead the gradient, well, assume it's just a vector field, and these are the magnitudes of the vectors. So it is really kind of the divergence. But if you took the gradient of this field, you would see that there's a maximum here. And you would see that there's like a contour here that gives like a maximum. But the Laplacian is talking about like the change in like the magnitude of change in the gradient. Oops. Yeah, the divergence of the gradient. So you basically look for the you got to identify the gradient first, and then you look for what is essentially the magnitude of change in the gradient. And so, like in physics, you'll find that like that's where things are happening, like where your Laplace is high or low, and generally where your Laplacian is high. That's where things are happening. That's where there's the most change in the system. And so, I don't know how it relates to explaining enthusiasm to a 5-year-old. I guess you could ask a 5-year-old to like reason about like how their friends being excited about something influences their behavior, and how like the prevalence of information, you'd probably ask about it in different terms, but how the prevalence of information influences their behavior, like the frequency of like words encountered, topics encountered, how does that like influence behavior? And so if you can think of like if you think of information spectrally like that, you can identify what the new trending topics are. And that's really what like Google Trends is the best way to explain my assessment of this line in the I Ching. Like when you have a Google trend for a keyword that is like when you have a change for that keyword in Google Trends, that is when the Laplacian is high. Like in the keywords that are like adjacent or nearby, like in Google Trends, like if they also experience change, like that's correlated, then the Laplacian is kind of high there too. But the space for like the Laplacian used in that context is a little different because you should model that as kind of a graph, and a graph like in terms of like there's this very interesting linear digressions. So I'm gonna borrow your podcast for a second, if you don't mind. There's this very like interesting discussion on pre-training language models for natural language processing problems that talks about like if you know what word-to-vec is. Word-to-vec basically assigns like an integer value to every word in the English language or whatever, and then when you process text, you like basically like swap like you might like process a sentence, and for the sentence you form like a vector that contains like more or less the maybe I don't know if I'm getting this precisely correct, but I have done like a little bit of machine learning with like back in 2012 where you used word vectors effectively, and so it wasn't word-to-vec, but anyway, so you swap out an integer for each word, and the integer is unique like per word, or the integer is like so for every unique word in the English language you would assign a unique integer. And one of the interesting things about this is it doesn't matter what integers are assigned to the words. They just have to be distinct for each distinct word. And the system will generally evolve to be the same, like more or less, like regardless of what the numbers are for the words. But what was interesting about this was that like those words fit like there's like this pre-training language model that allows you to do vector algebra. So the example that the podcasters gave was that you can take the word for queen and subtract the semantic concept of female, and subtract the word vector representing female. And in this system, then you could add the word vector for male, and suddenly you get the concept of king. And so there's these there's these vector algebraic relationships between all the word vectors that's been done like in this computationally expensive like pre-processing to provide people like a set of like well-trained like linguistic like analysis tools or language analysis tools where like it preserves these algebraic relationships between word vectors, and you can sort of extrapolate semantically with like operations that are similar to addition, subtraction, multiplication, they're like algebraic operations on vectors that like correspond to changes in semantics. And that matters for Google Trends because if you're gonna like identify the neighbors in the space of keywords for Google Trends, and you want to identify what the Laplacian is, then you construct a space where the neighbors in the space like give you the shape of the space over top which you calculate the Laplacian. More or less. I mean, it's not in precise terms, but that's basically how it works. And probably more clearly explained. But that's it for now. I'm gonna like make sure I got the right reading for this. I'm pretty sure it's correct, but I'll find out. Maybe I'm completely incorrect. In which case, I have the hidden lines that are useful for the receptive, because it like I've tried to Google things on the I Ching, And it's interesting how basic concepts from the I Ching are just like they're like missing from the internet. Like, so I don't know. I don't really know what hidden lines are, and I think it just means that there's something else you got to look for, and that you might have there might be hidden lines. Like there might be some other way to determine what those lines are. But anyway, that's it. I'm signing out, and thanks for watching. Oh crap! Cut the last bit of that stream, probably.